So what I would like you to do is I would like you to do these 3 warm-ups. They are not in your textbook, so that you can do them on a separate sheet of paper, backside of something, wherever. 3 warm-ups for you to do at this time. First one, I would add 5. And then that gives me 2x squared equals 36. Then I would divide both sides by 2. And that would give me x squared equals 18. Then I would square root both sides, and that would give me x here equals plus or minus 3 times the square root of 2. Yes? Okay, even root, so we got to take plus or minus because we're solving. Questions on that one?
Could you square root at the 2x?
No. You well, I shouldn't say that. You could, but you would get the square root of 2x squared becomes x times the square root of 2. Okay? And then that would equal 6. So then you would have, x here would be equal to plus or minus 6 divided by the square root of 2. And then you've got to go and you've got to rationalize your denominator.
Oh, I thought if you had an x squared term, you could square root it and you got rid of it.
You gotta isolate the x squared term first, which is what I did.
All right.
Then you can square root it.
All right.
Yes. Okay. Or if it was 4x squared, there you could, because 4 is a perfect square.
Okay.
You know what I mean?
Yeah.
Okay. But 2 is not a perfect square, so get rid of it first. Okay. Over here, what I would do first is I would divide by 2, giving me the quantity x minus 1 cubed equals 8. Then I would take the cube root of both sides, and that would give me x minus 1 equals 2. Then I would add 1, and I would get here x equals 3. Over here, I would first subtract 3. That would give me 4x to the 2/3 power equals 9. Bless you. Then I would divide both sides by 4. That would give me x to the 2/3 power equals 9/4. Okay. What power would you take to both sides? Squared? Nope. 3/2. Reciprocal, right? Okay. So I would take both sides here to the 3/2 power. So then that gives me x there. Okay. On the other side, taking something to the 3/2 is the half part does what? What does the half part do? Nope. We're not multiplying anything. We're taking to the power. The half part of 3/2. That'd be the root. So what root are we going to take? square root. Okay, so what's the square root of 9? 3. Square root of 4? 3 halves. Okay, so 3 over 2, but it's plus or minus, right? Okay, and then what does the 3 part of 3 halves do? So we got to cube that then, right? So we've got plus or minus 3 halves cubed is going to be plus or minus 27 eighths.
Could you put it in the root form, like in the beginning of the equation?
Sure.
That's what I did.
What I would like you to do now is, in your textbook, I would like you to turn to page 723. On page 723, you will find 4 different people all solved the exact same problem. Franco, Teresa, Donnell, and Martinez, not Martinez, Martinez, all solved the same problem. Okay? What I would like you to do now is I would like you to spend like 5 minutes comparing how all 4 of them solved the exact same problem. Jot down some notes right by each one as to what they were doing so that you can follow along with their work. All right, let's contrast and compare. Which of the 4 do we like the best? Martiz? Okay, Martiz. Okay. Okay, so let's save that one for last then. Okay. So let's talk about Franco and Teresa first. They looked kind of similar. Yes?
Yep. Franco doesn't have a check.
Okay. So what did they do first?
They look at the same things. They did that on here.
So what did they do first? They didn't do anything the same because looks like Martinez is a lot less shorter, a lot less work.
First, they squared.
They squared both sides, right? Oops. Okay, so first off, both Franco and Teresa squared both sides. Okay. All right. Then they did all that math. And then what did they do right in about here? But what did they do? They got it equal to 0. Okay, so they got it equal to 0, and then because they wanted to, what did they do after that then?
Then they time multiplied or distributed it.
They factored. Okay, because then all throughout in here they factored. And then how did they end up solving this problem? Set the factors equal to 0. And then solved it, right? Okay. Now, what did Teresa do that Franco didn't? Teresa checked her answers, okay, and she found that one of them went away. It didn't work. Okay? Franco just said, yeah, all that works. You know what I mean? Okay? So Franco didn't check. So that's why Franco gets the thumbs down. Teresa did a lot of work only to figure out then that x is just equal to 36. Okay? Alright? All that math is good. For Franco, it's all good up until the fact that he didn't check it. Okay? And didn't realize that one of his answers got kicked out. It's called an extraneous solution. Okay? It's a solution to the problem, but when you plug it back in, it doesn't make it work. Okay? So, let's go down by Donnell. What did Donnell do? First, she squared both sides, but she didn't actually.
Yeah, she just took the square root away.
Right. Now, in this particular problem, can we just take away the square root? No. Okay, so that's where she went wrong. And then all of the math after that is bad. What else didn't she do?
She didn't even square 7. She squared 1/7.
She didn't what?
Check.
She didn't check her answer to figure out that 206 wasn't going to work. Okay? So she didn't check either. Okay? So, Martiez, now, what did Martiez do first?
Let's take away the 7.
Okay?
We worked to isolate x.
He isolated the,
Variable. Square.
or the radical, right? And then, after he isolated the radical, what did he do?
Took away versions. Got rid of the root. He squared everything.
Then he squared both sides, right? And then, most importantly, what did he do last?
Check this out.
He checked his answer. Okay? He did the check to make sure his answer worked out. Okay? We're going to do that process. Now, we're going to go on to page 724.
25.
Or 7,
Oh, wait, no.
it is that, 724. Yeah, at the bottom, it's number 3, and then it's part A, B, and C. So it's all on 724. Okay? So, what I would like you to do now is I would like you to solve those 3 problems for x. Radical is isolated. Square both sides. That gives me 2x equals 9. Then what? Divide by 2. That gives me x equals 9/2. What do I have to do with that then? I gotta check that. 9/2 times 2.
18. 2 times 9/2 would equal 9.
Is 9, right? 2 times 9/2 is 9. Square root of 9 is 3. 3 is equal to 3. So it checks out. Okay. Questions on that? Part B. Radical isolated. Yep. So what do we need to do?
Cubic.
Cube both sides. Left side gives me 2x minus 3. Right side gives me 8. Then what? Add 3. 2x equals 11. Divide both sides by 2. X equals 11 halves. Check. 2 times 11 halves. That's 11, right? 11 minus 3 is 8. The cube root of 8 is 2. And 2 is equal to 2. So it checks out. Okay. Part C. First, divide both sides by 4. That gives me then the square root of x minus 6 equals 2. Then, square both sides. That gives me x minus 6 equals 4. Add 6. X equals 10. 10 minus 6 is 4. The square root of 4 is 2. 2 times 4 is 8 is equal to 8. Checks out. Get in the habit of checking your work. Okay? We know with certainty now that we just got 3 right answers because we just checked that work. Okay? We know for a fact those are the answers. Okay? Get into that habit. It's going to help you out tomorrow and the next day and the next day and on the test. Okay? Test, remember, is this week Thursday. Okay? Thursday this week for your test.